All right, we're going to start page 3 of ChemQuest 30. And the first question says, consider the reaction in which 410 grams of calcium nitrate react with just the right amount of lithium metal in a single replacement reaction. And it says how many grams of lithium are required. So we know that calcium nitrate and lithium, we need to know how much is required. In order to do this, I have to have a balanced chemical equation, even though I know that these are the two reactants. And so I know it's a single replacement, so lithium will replace calcium. Lithium is 1 plus, so when it replaces calcium, lithium, which is 1 plus, and nitrate 1 minus, just makes lithium nitrate. And then, of course, calcium is replaced, so it's left out. Is this balanced? Notice I have 2 nitrates, so therefore I'm going to have 2 lithium nitrates because I need 2 nitrates here, and if it helps to put parentheses here, I can. And now I have 2 lithiums, so now I know that my mole ratio of lithium to calcium is going to be 2 to 1. You have to have a balanced chemical equation in order to solve stoichiometry equation problems. So we're given 410 grams of calcium nitrate, and I already put over here calcium is 40.08, nitrogen's 14.01. Again, I'm getting this from the periodic table, times 2, because there's 2 nitrogens, 2 times 1, and there are 6 oxygens. 6 times 16 is 96. That adds up to 164.10 grams. So my first step is to divide by the molar mass. I have 164.10 grams of calcium nitrate for every mole of calcium nitrate. Once I know how many moles of calcium nitrate I have, I use the mole ratio. I know I have 2 moles of lithium for every 1 mole, what's understood 1 mole of calcium nitrate. Notice here the grams of calcium nitrate divide out. Here moles of calcium nitrate divide out. And now I have moles of lithium. And I want grams of lithium. Lithium only has a molar mass of 6.96 grams of lithium for every mole of lithium. And so if I multiply all of these out with a calculator, 410 times 2 times 6.96, and then divided by 164.1, I get 34.77. All right. And so I could say 34.8 grams of lithium. And I could actually argue that there's only 2 significant figures, so I could have actually just said 35 grams of lithium. It's okay too. The next one says how many grams of each product are produced. Well, the product is going to be lithium nitrate and calcium. And so one of the things that I know, if I take this first step, 410 grams of calcium nitrate, and I divide it by 164.1. Right here, I know that that gives me 2.49 847. And so I'm going to say it gives me, well, I will just say 2.5 moles of calcium nitrate. And then I can use the mole ratio here, right? So if I have 2 moles of calcium nitrate, for every mole of calcium nitrate, I'm going to have 2 moles of lithium nitrate to every 1 mole of calcium nitrate. Okay. And on this one, if I have for every 2.5 moles of calcium nitrate, I have 1 mole of calcium for every 1 mole. Notice this is a 1 and that's a 1. Of calcium nitrate. Now here, I know that calcium, that's going to be the easy one, the calcium is going to be 40.08 grams of calcium for every 1 mole of calcium. So moles divide out, moles of calcium divide out, and then if I do this, 2.5 times 40.08 is about 100 grams of about 100 grams of calcium, and I'm just going to say 100 grams of calcium. And then here I'm going to say 2.5 lithium nitrate. I already did the molar mass over here, 6.94, 14.01, 4868.95 grams of lithium nitrate for every mole of lithium nitrate. And so if I do the math, 2.5 times 2 times 68.95, I get about 345 grams of lithium nitrate. Okay, now that one we had to start from scratch with a balanced chemical equation. This one, question 2, we already have a balanced chemical equation, so that makes it easy. We are starting with the given 250 grams of sodium sulfate, and it reacts with calcium phosphide to produce sodium phosphide and calcium sulfate. We want to know how many grams of sodium phosphide will be produced. So step 1, we have to turn grams of sodium sulfate to moles. And I did the math already. 2 sodiums is 45.98, 1 sulfur is 32.07. Again, I'm getting these from the periodic table. 4 times 16 is 64. So the molar mass of sodium sulfate is 142.05 grams of sodium sulfate for every mole of sodium sulfate. Now on here, I look at I want to know how much sodium phosphide is produced. Notice there's 2 moles of sodium phosphide are produced for every 3 moles of sodium sulfate reacted. So my mole ratio is 2 moles of sodium phosphide divided by 3 moles of sodium sulfate. That is my mole ratio. Here are my grams of sodium sulfate divided out. Now my moles of sodium sulfate divide out. I now have moles of sodium phosphide. Sodium phosphide has 3 sodiums, which is 68.97. Again, it's 22.99 on the periodic table. And phosphorus is 30.97. Add those together. It's 99.94 grams of sodium phosphide for every mole of sodium phosphide. Very important that you're showing units. When I do the math here, I have 250 times 2 times 99.94, enter. I'm dividing that by 142.05, and I am still dividing that by 3. And I get 117.25 because I only had 2 or 3 significant figures. I'm going to just round that to 117 grams of sodium phosphide Okay. Now, we're going to consider the following combustion reaction where butane, C4H10, reacts with oxygen to produce carbon dioxide and water. It says 75.3 grams of butane, C4H10, reacts with plenty of oxygen, usually from the air. That's where they get the oxygen. And how much carbon dioxide and water are produced. So the first step is to change that butane into moles. Well, butane has 4 carbons, which are 12.01 each, and 10 hydrogens, which are 1.01 each. That adds up to 58.14. So step 1 is we're dividing each of these. We know 1 mole of butane has a mass of 58.14 grams of butane. And I'll do the exact same thing here. Okay. Now I need my mole ratio. How many moles of CO2 are there for every mole of butane? Well, in my balanced chemical equation, it says there are 8 moles of CO2 for every 2 moles of butane. Now, if I wanted to change that right now and say 4 to 1, I could do that, but I don't need to. On the other one, I have 10 moles of water for every 2 moles of butane. Again, I can leave it 10 to 2, or I can simplify that 5 to 1. The mole ratio would be 4 to 1 or 5 to 1. Now I need to know the molar mass of carbon dioxide because I want to know, it says, what's the mass? So what is the mass of CO2 produced? So I have to look up my molar mass. Carbon is 12.01, 2 times 16, oxygen is 16. That adds up to 44.01 grams of CO2. And here, water we know is 18.02. You'll notice that some of these elements we use in a lot, like carbon, hydrogen, oxygen. Hopefully you have those molar masses memorized so you don't have to look them up every time. But you don't have to memorize them. You have the periodic table available to you at all times. So if I go through 75.3 times 4 times 44.01 divided by 58.14, I get 229 grams of CO2. But I was just looking at my answer key, so let's go ahead and do that math. 75.3 times 4 times 44.01 divided by 58.14. And actually, I get 228 grams of CO2 to the nearest 3 significant figures. Okay, here, how much water do we get? So we'll take 75.3 times 5 times 18.02 divided by 58.14 equals 118, or we'll even say 116.69, sorry. We'll round that to 3 significant figures, and we'll say 117 grams of water. All right, so there we have page 3.